So welcome to our week 3 win form. It's basically going to be a review in preparation for our test that's coming up this week. So I'm going to take the time to actually go through every single problem that's here in your work section. So those people who actually watch the video will get a really good review and be able to have some reliable stuff here to study from. Um, I'm just going to jump right into it. So there's about 16 practice problems here that are very similar to problems on the test. And we begin with this first one, which is a graphing problem. It says use the dog walking position versus time graph to answer the following. What is the dog's average velocity? Is the first question. And if we look at this graph, we have position on the y-axis, time on the x-axis. If we're trying to find the average velocity, we're basically looking for the slope. So I'm just going to go ahead and write that here. And the slope in this case, if we look at this graph, remember you have to pick 2 points. You can do rise over run. I'll just pick the first point, the origin, and then this point at position 10, 1 second. And if you make a rise over run right triangle here, you'll see that the rise is 10 and the run is 1. You guys know rise over run would be 10 divided by 1, which in this case is going to be 10. And then our units will be meters divided by seconds. So this is the average velocity for the dog. It would be 10 meters per second. How long did it take the dog to walk 40 meters? Well, if you look at position 40 meters, if you follow it across, and then you come down to see how much time has gone by, it's taken 4 seconds. So that would be 4 seconds, the answer for that one. What does the slope of the line tell us? Well, we just found out the slope of the line tells us our velocity. Okay, so there's several questions that might ask you questions about graphing that deal with these types of things. Again, one of the big keys here is just that on a position time graph, the slope of this line is going to be the velocity. And then obviously at any point on this graph or position, you can come over here and find how much time has elapsed for the object to be in that position. Moving on to number 4, it says, after his walk, your dog decides to run. He starts running at a constant speed of 3 seconds and then stops and remains still for 2 seconds. You can see in this graph that they've provided for you, they want you to sketch the distance versus time graph for the situation. It goes up to 5 seconds. In the first 3 seconds, he's accelerating at a constant speed. You can see here there's no positions. They don't really care what kind of velocity you give him. They haven't told you what his positions are. The fact that they tell you he's at a constant speed, though, means that we're going to have a straight line. You remember this from our interpreting PVT graphs. And we're going to have a straight line till about 3 seconds. There's no curve to this, right? It's just a straight line. That's constant speed. And then for the remaining 2 seconds, they say that he remains still, which means he's going to remain at that same position. So we're going to draw a flat line going across here, horizontal to the x-axis. So 3 seconds of constant speed, followed by 2 seconds of remaining still. So that's how that graph would look. And there will be questions we have to interpret graphs that you have there. So express the following movement as positive or negative. It says a baseball is hit and moves to the right with a speed of 3 meters per second. For this, you have to remember that we discussed at the end of last week, on an x-axis, to the right of this y-axis, all these numbers are going to be positive. To the left, these would be negative. On the y-axis going up, these values would be positive, and going down would be negative. So if we're trying to express these vectors for speed and distance, and positive and negative do indicate a direction. So it says here the baseball is hit and moves to the right. So if it's moving to the right, then we have a positive vector there. So we're going to want to put a positive here. A boy jumps down off a 10-meter cliff into the water. So if the boy is up on a cliff and then he jumps down, that's going downwards, which would be a negative value. So it'd be a negative displacement. A train moves to the left with a constant speed. If it's going to the left, it's going to be negative. During takeoff, a plane climbs to an altitude of 30,000 feet. So again, the displacement in this case is going up, which would have been positive. All right. Number 6, fill in the tables with the correct word from the word bank. Um, and in this case, we're dealing with scalar and vector quantities. So over here, you would have distance. And then as in addition to distance, you'd have scalar because distance is a scalar quantity. And then over here, you'd have also speed. Again, distance and speed are scalar because they only give the magnitude. They only tell you the amount. And again, that would be like the total distance that you travel doesn't give you the direction from where you started. And then speed, same thing. It's just going to tell you how fast you're going. Like if you're in your car, you're going 50 miles per hour, that's your speed. But if you want to give someone your velocity, that would be a vector because it gives the direction as well. So we'll go to write vector here. Displacement is also a vector quantity. All right, so I think we got them all. So that's how those two break up. So number 7, it says Henry noticed his dog running in the yard and decided to record the dog's position in 5-second intervals. After the dog sat down, Henry created the following table. And you can see here that at the original time, the position was 49. That's going to be very important. And then it says we want to find the dog's displacement. So if we go from 49 to our final position at time 15 seconds where the dog stops and sits down, the new position is 58. So if we want to find the displacement for this dog, it would just be 58 minus 49, which is 9 meters. Again, we're just looking at the starting position, final position, and our displacement is always going to be a straight line from where we started to where we finish. The next day, Henry noticed a hamster running around and created another table for the hamster. We're trying to find this hamster's displacement. Do it the same way. You're going to use the initial position and the final position. So in this case, it'll be 61.3 and 49.6. And 61.3 minus 49.6 gives us a value of 11.4. Meters, or centimeters in this case, right? Pay attention to units. A guy rides his bicycle 100 meters east for number 9 here, then 300 meters west, and then 400 meters east again. You remember for this, we should draw a picture here. So this person is riding their bike 100 meters east. That would be to the right 100 meters. And then from there, he goes 300 meters west. So this whole thing right here is 300. And then from there, he goes 400 meters east again. So he's going to backtrack here. And this whole distance from here to here would be 400. Now, because these are overlapping, an easy way to handle this, this is displacement in the x direction. We can just change our symbols here. Since this is east, we'll just make that a positive value. And then over here, this is west, that would be a negative. And then east again would be positive. So this is where the signs become important because it makes it very easy. You can see that if you just look at it graphically, it can be confusing because you want 100 east, then 300 west, and then 400 east. It's much easier just to put the signs based on the directions here. And then from there, you can actually just go ahead and add them. So it would be 100 meters plus negative 300, and then plus 400. So in this case, it would be 100 plus negative 300 would give you negative 200. Negative 200 plus 400 gives you a total displacement of 200 meters. And then the distance in this case would be the addition of all of them without any negative or positive signs. Remember, we don't want to know the total distance you travel, you just add all the distances together. So 100 plus 300 is 400, plus another 400 would give you 800 meters. So that's that one, number 9. Number 10, a guy drives his car 1,200 meters north, then 400 meters east, and then 200 meters north. This is going to be a problem where you actually have to use a little bit of the Pythagorean theorem to solve it. So a guy drives his car 1,200 meters north would be a positive value in the y direction. And then 400 meters east would be also positive, but in the x direction. And then 200 meters north would be a positive value again. And if we were to graph this to see what it looked like, you'd have someone who went up 1,200 meters. And then after they went up north 1,200, they went to the right 400. And then from there, they went another 200 north. Okay, so from our starting position to our final position, we're going to have to use the Pythagorean theorem. You can either do this graphically by just looking at our values and making a little right triangle here from our starting position to our finishing position. This gives you a little right triangle from here to there. And you can see that one side of our right triangle is going to be 1,400. And then the other base of our triangle would be 400. And you can just do a squared plus b squared equals c squared. So that's the graphical way to do this, just by looking at it. You should also know how to do it using some of the stuff we've talked about. So if we look at the x displacement and the y displacement, for the x displacement, there's only one value, the 400 meters east. And then for our y displacement, there are two values. There's 1,200 meters. And it's positive because it went north. And then another positive 200 meters, which is going to give us a total of 1,400 meters. So again, we can use A would be 400, B would be 1,400. So if we actually write this out, it would be 400 squared plus 1,400 squared equals c squared. And once you simplify this, 400 squared, so 400 times 400, that's going to give you 160,000. Change that to scientific. We can actually get our square there, I think. So 400 squared would be 160,000. It's right over here. And then we're going to add that with 1,400 squared. And that ends up being 1,400 times 1,400. This is 1,960,000. So from this step, this is where I wanted to finish, and I'll let you actually calculate this on your own because my scientific calculator is not showing it. But when you add 160,000 and 1,960,000, you can see that that still equals c squared. To actually find the value of your displacement, which is c, you have to take the square root of all this. And then if you take the square root of this side, that cancels out the square there. So 160,000 plus 1,960,000, take the square root of that value, and that will give you your displacement right here. And then for our distance, we don't actually have to do all that. Again, our distance is just the addition of all of our distances. So in this case, it would be 1200 plus 400, which is 1600, plus 200 would be a total of 1800 meters. Okay, so number 11, Larry, Mo, and Curly decided to run the 100-meter dash. Larry finished in 10.06 seconds. Again, 100 meters is going to be important, so we'll underline that. Larry finishes in 10.6 seconds, Mo is 10.22, and Curly is 10.49 seconds. They're all running the same distance, so we don't actually have to calculate their speed to decide the order that they finish or cross the line. The person with the fastest time, or the person with the smallest time, is actually going to be the person who travels the fastest. And so if we look at this, Larry is going to finish first, and then Mo would finish second, and then Curly would finish third. So they're actually already in order of how they would cross the line. So again, when you're running a race, the fastest time will be the lowest one. And in this case, Larry's the first, second, and then third for Curly. Number 12, the cast of Jersey Shore is running from a Guido eating monster. Polly runs 1900 meters in 295 seconds. Mike runs 400 meters in 39 seconds. And JWoww runs 500 meters in 90.2 seconds. Benny runs 120 meters in 15 seconds. And Snooki falls instantly. So who has the fastest speed? For sure it's not Snooki, because she fell down instantly, so she doesn't have a speed. But if we're looking at speed is just going to be distance divided by time. So all you would have to do is for each one of these people, beginning with Polly, you would just take their distance and divide it by the time that they're running, and then you could compare all their speeds afterwards to find out who actually had the fastest speed. Number 13, in 2009, Mind That Bird won the Kentucky Derby with 50 to 1 odds. The Kentucky Derby is a race of 2,012 meters, and Mind That Bird finished the race in 122.66 seconds. This is a very simple, straight up distance divided by time question. We're trying to find speed. And so if we actually plug in our values, we would get speed equals 2,012 meters divided by our 122.66 seconds. We can do that one. So 2012 divided by 122.66. That gives us 16.4 meters per second. For that horse, Mind That Bird. Number 14, a car is traveling at 18.2 meters per second. How far will he go in? In this case, we're looking at the speed of the car. And it looks like they actually cut off part of the problem. But we're looking for the distance, and we can see here that they're giving us time. That is a terrible problem. I'm going to cancel that one. Okay, so I want you to go ahead and skip number 14. It's obviously a flawed problem. They didn't give you the distance that the person traveled, which is what you need to be able to find out how much time it took for the car to be traveling that speed. We're going to go to move number 15. It says, what is the speed of, and it says a soccer player that can run 30 meters in 3.5 seconds, a car that travels 20 kilometers in 1.5 hours, and then a plane that can travel 60 miles in 1.2 hours. Every single one of these problems is just a speed equals distance divided by time problem. So you can just get their distances and then divide it by their time right there. And you'll be able to get your speed. The final problem is this Harold and Kumar problem. And it says Harold and Kumar decide to race to White Castle 150 kilometers away. So that's going to be a given information. 150 kilometers is a distance. Harold travels at 90 kilometers per hour, which is going to be his speed. And Kumar travels at 60 kilometers per hour, which is his speed. How much earlier, so earlier is referring to time, does Harold get to White Castle than Kumar? So if we're trying to find time, speed equals distance over time, but if we're trying to find time, it's going to be distance divided by speed. And so for Harold, it would be his distance of 150 kilometers divided by the time it took him, or I'm sorry, rather by the speed that he was going, which is 90 kilometers per hour. And that'll give us our time in hours. And then if we're trying to find the time for, again, this is Harold. If we're trying to find the time for Kumar, it's going to be his distance, which is the same one. They're both going the same place. So 150 kilometers divided by the speed that Kumar was going, which is 60 kilometers per hour. And again, that's going to give you his time in hours. Once you know both their times, you just have to subtract the faster one from the slower one. In this case, we know that Harold's going to get there first because he's going 30 kilometers per hour faster than Kumar is going. Okay, so this is your review for the test. You can see that there's a lot of speed problems. There's some graphing that you have to know, some basic things about position and time graphs, consisting of where the car is going at a certain speed by looking at its slope, and then also, where it stopped. And so other concepts that are also important on the test are going to be things like distance and displacement. Those example problems where you have to know, which direction is positive, which one's negative, and then add them up is also going to be there are going to be several problems on that as well. So if you have any questions about this review or you need any help, any additional help, just a reminder, there is tutoring on Mondays, well, not Monday for this week, but on Wednesday, Thursday, and Friday of this week, there'll be tutoring. And I'm looking at probably giving the test on Thursday, so you should probably try to come in either Tuesday, Wednesday, or Thursday morning. Okay.